I want to demonstrate Fibonacci number instead of iteration using recursion this time around. The Fibonacci numbers, commonly denoted f of n, form a sequence called the Fibonacci sequence, such that each number is the sum of two preceding ones starting from 0 and 1. That is, f of 0 equals 0, f of 1 equals 1, f of n equals f of n minus 1, plus f of n minus 2 for n is greater than 1. So like I demonstrated in the last iterative solution, a Fibonacci sequence, it starts with 1 and 1 in an array. 1 plus 1 equals 2, and then you take the last two numbers right here, 1 and 2, add those together, and that gets your next number, and then you continue doing that, and that's your Fibonacci sequence right there. So this is what we're going to code an input number. So recursion requires a base case, and it works differently than looping. The function calls on itself, the parameter is input, and it kind of works like a call stack. The function will keep running until the base case is met, and that's its stopping point. So here's our base case. If n is less than 2, return n. It's that simple. Because if we're looking at the two numbers before the current number in the Fibonacci sequence, so that's why it's minus 2. And then we'll return fib, the function that we created, the number minus 1 added fib, the number minus 2. Works. And that works too. This is an O of n linear runtime because we're having an input number and it's decreasing one by one through each recursive call, function call.